Alright, let's dig into creating a Makefile for our compass example. And just as a reminder, our compass example doesn't really do anything yet, it's just bare setup and loop functions. That's something we'll add functionality to later on. So for the Makefile, we'll start by just creating a file called Makefile. And technically I think the standard is to use a capital M, but either way, uppercase Makefile or lowercase Makefile will work. And essentially what a Makefile does is it makes it easy for you to not have to remember an entire compilation command. You don't have to up arrow through your command line history to figure out what you typed in, what was the special invocation for compiling your program. So for that reason, let's just start by copying it out of the command line history. We'll look for the last time I called compile. So here's the command that we would need to remember each time. And so I can just paste that into my Makefile. And now I need a shorthand name for how to run that command. It's pretty standard to start with just all. It's the default target. This is called a target. It's the default target that you'll see a lot of tools use when they're calling your Makefile. A Makefile itself, when you call make without any arguments, will just call whatever the top target is in the file. It doesn't actually need any specific name. But now if I call make, well, I'd have to be in the correct directory for make. If I call make, we'll see that it gets called from the current directory, which is inside the compass directory. And the Arduino YAML file is not one level up from here. One level up from here is the list of all these files. If I want that Arduino YAML, I'll need to go 2 levels up. And if my reading comprehension was better and I wasn't just trying to predict what the error was, I'd notice that it's also complaining that there's no such file or directory compass. So now that we're in this directory, I can just say compile the sketch in the current directory. Everything's relative to the current Makefile. So when I type make, it'll run this top target, and I don't have to worry about remembering this entire command. It's basically just like saved away in this text file. And after about 11 seconds on my machine, we'll see that it generated the build directory just like it was doing before. And inside the build directory, we have the binary file that actually gets uploaded. Speaking of uploading, it would be good to have a target called upload. So looking through our commands where we did upload, I think this is the one that was successful. And again, I'm not looking for a file, or folder rather, called compass. We're already in the compass directory. And likewise here. So we should be able to say Arduino-CLI, we're going to upload the sketch in the current working directory. And instead of looking for it in some temporary location, you can actually find the binary file inside this directory. It's also going to pick up on this sketch.yaml file inside exercises compass. So all of these options are all automatically fed to that Arduino-CLI upload command. So let's see that that works. If I type make, it actually just goes for the first target again. So we'd have to wait 11 seconds here for this to make for me to move on and try something else. This probably won't come as a shock, but if I actually want to upload or call my upload target, I can say make upload. And that instead will run the target with that associated name. And that sketch was effectively uploaded. Let's dig into our Makefile and make this a little bit more useful. I could demonstrate again, and probably should demonstrate again. If I call make all, or whatever you want to call it, just the default, you'll notice it will recompile again from scratch. And that's because I'm not really using the Makefile how it wants to be used. Instead, I should really have my targets be the files that I want created. So what do I really mean when I say make all? What I really mean is that I want a specific file to be generated. And the file I want generated is in the build directory inside esp32.esp32.xiao esp32s3, and then the file inside there, I'll have to remember what the name is. It's this compass-ino.bin. So that's really what my target should be. My target is I want to output this compass-ino bin, and it should be inside this file. Sorry, this folder, sequence of folders. So that's really when I want to run Arduino-CLI compile, is when I want to produce this file. Now I can say for all, it should really only run if this file has changed. So you can think of this as target and dependency. And I really don't like the name all here. Let's change that to compile. So now when I say compile, what I really mean is check to see if this dependency here has changed, and if it has, then I need to regenerate it. And how do I regenerate it? I recompile it. And currently, this is really not much better than what we had before. So if I say make compile, it sees that this file, actually it's even worse than before, it sees that this file already exists, so that dependency is already satisfied. This file exists, and more importantly, it has a timestamp, a date modified stamp associated with it. Okay, so why do I say the date modified stamp is important? Well, what we'd like to say is if this source file, not the output binary file, but if this source file has changed more recently than our output binary file, then we want to recompile the output binary file. So for example, maybe inside the loop function I say something like, I don't know, let's just look at what Copilot's automatically generated here for us. I'll just save it, angle map, sure. This is really just nonsense code from Copilot, but let's just leave it there as something to compile. If I say make compile, we'll see it says nothing to be done for compile, and that's because I actually haven't told make that this binary is dependent upon this compass-ino file. And so I do that by putting it here. And now since I've made a change to compass-ino, if I type make, it'll call make compile. And about 11 seconds later, I get my generated output. And if I say make compile again, nothing is to be done for the compile command. However, if I come in here and make some changes and call make, it'll pick up that compass-ino has been updated, has been changed more recently than the binary file. So this dependency, this target needs to be regenerated because this dependency has been updated. So this is a nice pathway for your commands. I typically like to have something that's human readable here, and on the right hand side the actual file that's associated with that target, and then the command to actually generate that file. One more thing that's useful is to tell make that compile is not actually a file. It's nothing that actually exists. This isn't going to matter much for this really simple make file, but this is a good habit to get in. The thing on the right hand side of the colon should almost always be a file, just like we have here with the binary. And if it's not, you should tell make that it's not. And we should do the same thing for upload. We can say the upload target's not actually a file. That'll help make out a little bit. One thing that's important for upload, though, let's say that I haven't, well, actually, let me just say what happens when I call make upload. Make upload will call our upload command, which will flash the microcontroller. One downside to the way this is currently configured is if I do make a change here, here's a simple change. If I call make upload again, you'll notice all it's doing is calling upload. It doesn't actually compile our sketch so that a new sketch that reflects the changes we've made gets uploaded. So that was sort of worthless. I just overwrote what was already on the microcontroller. So we should really tell the upload sketch that it also depends on changes to this Compass INO file. So now if I call make upload, it'll still not compile it, and that's because I told it to depend on the wrong thing. The Compass INO file, it says, okay, that already exists, so all the dependencies are met, so it just calls upload here. What I really wanted to do was say it depends on the binary. Because when I say it depends on the binary, and I've got an extra colon at the end, when I say it depends on the binary, it then checks the binary target, and then if the binary is sort of out of date compared to the source file, it will then compile and then upload. So let's check that one. Make upload. And since the last time that I've called upload, or sorry, the last time that I called compile, I have made changes to compass.ino. So we should see a compile and then an upload here. So we call upload, it checks this timestamps of the files, it calls compile, and then after it's done compiling, it calls upload. So now, with this makefile in its current state, any changes I make to here, if I call upload again, it'll automatically recompile it. And if I haven't made any changes and I call upload, it'll say dependencies have been met. So for example, make compile won't do anything. And so we won't have to compile every single time you want to upload, which is different than the Arduino IDE. So for those of you who have had problems with your board saying no serial interface, and then you had to click verify, and then you had to wait 30 seconds for it to compile again, the Arduino-CLI and Makefile approach should really cut out a lot of that waiting time. If you say make upload, and it fails, and then you say make upload again after pushing the reset button, it won't have to recompile, so that's where your time savings comes in. The last thing I'll do is add a command called clean, and Copilot was actually able to predict that because it's a pretty common command to run. So we'll add this clean command, and then the last thing after that is we'll add a variable here at the top. They're not strictly necessary, but I think they'll make this code easier to use and easier to copy into other sketches when the time comes. So what should clean do? Well, that's pretty much what it should do. Whenever you call make clean, it'll remove everything in the build directory. So if I type ls, we have a build directory. If I call make clean, it runs the command remove the build directory, and now the build directory is gone. So I'd have to call make compile to remake the binary, or I could just call make without any arguments, and it would do the same thing. Last thing I said was a variable. So you'll notice that this is copied in several places, this string here. So I'm going to cut it and replace it with a variable build directory, and then we'll set that variable. So now this is the exact same makefile I had before. It should work if I say make compile, or just make. Oh, I may be wrong about the default. So if this is not all, it may get upset about that. Or did I change directories at some point and not realize it? That looks like it might be more likely the case. Yeah, I changed directories. I must have closed the terminal window instead of minimizing it. So now this works the exact same way it did before, but it should be a little bit easier to copy this makefile over to a new directory without having to change much, except for basically the word compass. And speaking of the word compass, we can call that the sketch. Maybe we'll call it the sketch name. And now anywhere we see compass, we can replace that with the variable. The make command still works, and the make upload still works. And if I've done everything I sought out to do, when we create a new sketch, let's call this test to delete. I should be able to copy from Compass the Makefile What am I missing there? Oh, capital M. Into the test and copy the sketch YAML file into the test. Close both of these. Look at my exercises, open up test. There's nothing interesting in here. Looking through here, all of this can stay the same also. And looking in the Makefile, I believe the only thing I'll need to change is this one, to the name of the sketch itself. Let's see, does the word compass show up anywhere here? It doesn't look like it. So now I should, from the test to delete directory, be able to say make upload, and it will both compile it and then upload it to our board. Compilation worked, and immediately after compilation, upload started. Then a reset, and that new sketch that doesn't do anything is now running on the board. So that should be the steps for starting a new sketch. Call sketch new to create the template, the directory, and the INO file, and then copy over those two files, the sketch.yaml and the make file. And that should hopefully speed up workflow.